Okay, this video is going to be the big long video about how to take your airplane design and model it in graphing software DESMOS to basically graph all of these lines to lay out this exact, all these fold lines exactly as they are. So the first step, I'm just going to recap where we've been and get you to kind of where we're going to need to be to start this process. So the first step obviously was to make an airplane, unfold it, draw all the fold lines, make sure that that airplane design has some sort of perpendicular section in the middle. If it doesn't, you can either make a different airplane or you can just simply draw a line across the middle somewhere, across perpendicular, and that'll work. We can use that. We're going to use mark this crosshair that's a perpendicular crosshair in the middle as 0, 0, and that'll make it a basis for our coordinate grid. And you can see that I've written some coordinates in here, and how I got those is I measured the distance from the middle, from that 0, 0 point, and that was 1 3/8 of an inch, and so it's 1 3/8 to the right, but not 0 up. And then this would be the opposite, the other way. I don't need to measure both of them. I can measure this one, and then this one should be the opposite. Now, because our folds and our lines aren't perfect, it's possible these two numbers in actuality aren't the same. But for the sake of this build, we're trying to model the plane as if we had done it perfectly. If we had built it perfectly, we're going to make sure that those two numbers match because it's symmetrical. Okay, and then when I measure up and down, you can see, oops. In this case, the first number is 0 because that's the x, and I didn't move this way. I just moved straight up. And how far did I move up? Moved up 3 and 3/32. Okay, so that's the general first step, is to measure along what would be the x-axis and the y-axis. X-axis horizontal, y-axis vertical. Once you get to the edge, and by the way, the edge of the paper this way, since it's the middle and a piece of paper is 8.5 inches, everyone should be measuring 4 1/4. If it's not 4 1/4, then this actually isn't in the middle. And if you got something slightly different than that, it's okay to keep that, but that's what you should be getting. So then comma 0, and then this over here would be negative 4 1/4, comma 0. And now, since I know how far the edge is, everything going this way is 4 1/4. So everything on this edge of the page is going to start with 4 1/4, comma something. 4 1/4 down here, 4 1/4. Make sure it's on the page, comma something. Everything on this edge, and everything on this edge is going to start negative 4 1/4, comma something. And then to find what the next thing is, well, that's just how far you are from 0. So here's 0. I'm going to move up. So I just measure from there. Okay, and I'll do a quick measurement here. I get 2 7/8. So I'm going to write 2 7/8. And the nice thing is again, because it's symmetrical, this corresponding point on the other side would be negative 4 1/4, but it would still be 2 7/8. So the point being here is that if you're using the logic of this grid, you don't have to measure everything a bunch of times. There are way fewer measurements than you might think you need to do. Okay, and then likewise, if I measure straight up to the top, which in my case was, well, this page is actually 4 1/4, so 0, comma 4 1/4. That means every coordinate point here ends in that number. Okay, so some number, comma 4 1/4. Okay. And to find out what that number is, all I have to do is measure from this starting, the y-axis here, over to that line. So if I measure from there to there, I get, that's about in between. So instead of, that'd be 1 7/32. Okay, and so then this would be negative 1 7/32, 4 1/4. So I'm just trying to show you the process here. The corner bits you don't have to measure at all. Once you've measured to the top, you know that the y coordinate is 4 1/4 because that's the top coordinate. And I've already measured to the right, and that was also 4 1/4. So this is 4 1/4, 4 1/4. Okay. And I'm only going to briefly mention that when I measure down, that means a y-coordinate of negative. And I'm going to just jump over for the sake of time, because I don't want to do that again and again and again. And then if I keep doing this, I will get all of these coordinate points along the axes and around the edge of the paper. The only coordinate, oh, I should mention down here, you can see it's everything down to the bottom has the same y-coordinate. They're all, for me, in this paper, -6 5/8. Now, there are some coordinate points you cannot find through that method. So you can see right here, these two coordinate points I couldn't find through that method because they weren't on the edge of the paper and they weren't on one of these crosshairs, the x and y axis. So the way I found those was I took a sheet of paper and then I lined up, this is a perpendicular angle, and so I lined up one of these lines with the x-axis and the other line with the point. So if I zoom out here, one end with the x-axis, that's here, and the other end with the point, like so. And then from there, I just marked where the origin was. So here's my 0, 0. And I mark where my point was. Here's my unknown. And then I can remove this. And now I can just measure this distance as the x-coordinate. I can measure that distance for the x. And then I can go measure that distance for the y. And that's what I did, and that's how I got these numbers, 3 1/16, 1 7/32. And because it's symmetrical, I didn't have to remeasure this one. I just made the opposite. Okay, so that's how you can go ahead and get every coordinate point. So that's kind of in the past. The next step that we started this week was to find the slope of any line that was not straight up or horizontal or vertical. Anything had a slight angle to it. And I showed you, and it's in a video, but I'm going to recap everything in this one video. You would need to go to DESMOS. And so here we are. Here's DESMOS. You're going to scroll down, and you're going to go to the scientific calculator. There we go. And the first thing you're going to do is you're going to just type the division symbol. Because we're going to find slope, we have to use the slope formula. And the slope formula goes like this. Oh, sorry. Let me click over here. Slope formula, m is equal to y2 minus y1 over x2 minus x1. So I need two coordinate points, and then I need to just subtract the y's and subtract the x's. You need to do it in the same direction, so y2 minus y1, x2 minus x1, can't flip them. If I do that, then it will work out. So in the example in the video, I did this line, and I picked this point and this point. And so y2, if I make this y2 and this y1, or this is the first point, this is the second point. Here's y2, 4 3/8. There's y1, 1/16. And so I would go over to the DESMOS, and I would type in the top of this. Oh my goodness, something just crashed? Oh, no, it didn't. Sorry. It looked like it crashed. That was weird. Okay. So I'm going to type in 4 3/8. So the space is important, so it understands it's a mixed number. Minus 1/16. Okay. And then underneath that, I'm going to do the two x coordinates, which the first x coordinate was, the x2 is 0, minus, and then it's minus a negative, which really means to add, plus 4 1/4. And it's going to give me a decimal, but if I click this button, I will get the fraction. So 69 over 68. And so that is the slope between those 2 points. And then I can use that number, I can document it on this sheet of paper as my slope. 69 over 68. And let me go back and show you just what I mean by that. Why can't I get my mouse over here fast enough? There we go. So I just wrote that the slope here on this line is 69 over 68. And so you can document on here all of your slopes. Now, I'm going to pause the video here, and the next instructions I'm going to give are actually live during class. And this is when we'll take this information. Once you have all the points and all the slopes, then we can take this information and we can graph it. And so that'll be the next part of the video. Okay, so the next step is to go to DESMOS.com and then click the graphing calculator and type in x equals 0 and y equals 0. Okay, why do you think we start with those two lines? So they're just the x and y axis, but we need to graph them because we need to actually limit them, because the x and y axis on a sheet of paper doesn't go up forever, down forever, right forever, left forever. They have a stopping point. So if I go over, whoops, there we go. If I go over here, what is the stopping point on the right side? How far do I go over? 4 1/4. And actually, all of you, if you did it accurately, should have that same fraction, because the sheet of paper is 8.5 inches, and half of that is 4 1/4. So what I'm going to do here, and if I look at the other side, I started at negative 4 1/4, and I ended at 4 1/4 for x. So if I go over to here, to this way, there we go. What I'm going to write, wow, is I'm going to do squiggly brackets, okay, negative 4 1/4 is less than, okay. Oh wait, I'm doing this on the wrong one. Sorry, that's the vertical line. I need to do that on the horizontal line. Squiggly brackets, negative 4 1/4 is less than, x is less than 4 1/4, end squiggly brackets. Okay. Oh, whoops, squiggly brackets. There we go. Okay. And now what you're going to see here, you can see it on the graph, is that the blue line doesn't go forever anymore. Do you see how it stops? It stops on the left and stops on the right. Okay. So the blue line's horizontal, so I need to enter in its starting point and end point, which for us should all be something close to negative 4 1/4 and positive 4 1/4. Unless your plane was landscape, then obviously that's a larger number. But then you need to figure out where it starts and stops going up and down. Okay, and so I'm going to switch back to here. And here's the top sheet of my paper, and the top number is 4 3/8. And if I look down here at the bottom, it's not the same number, it's negative 6 5/8. So when I look at that vertical one in DESMOS, I need to go here and type in those numbers. So I started, squiggly bracket, negative 6 5/8 is less than, okay, y, because it's up and down, which is less than, then my top of mine is 4 3/8, end squiggly brackets. Okay. And now when I look at DESMOS here, you can see that my crosshairs have a starting point and an end point. Now here's what I'm going to recommend that you do. I would make your crosshairs the same color. I'm going to make mine, you can click here on DESMOS, you can just click here and hold and pick a new color. I'm going to make mine both red because they stand out a little bit better on that screen. And so now I have two crosshairs, but they actually end where the paper ends. Okay. So I'm going to pause the video there and let you do that. The next thing we're going to look for is every vertical and horizontal line on our entire page. Okay. So I'm going to focus on the edge of the pages. There's a horizontal line at the top of the page and the bottom, and a horizontal line on the left and the right. But if you have more purely horizontal or purely vertical lines, we can do those as well. I think on mine, those are the only purely horizontal lines outside of this little segment right here. Actually, those coordinates are totally wrong. Oh, I got them flipped. That's my fault. Uh, yeah, so I need to correct those. But I have this little horizontal segment right here in the middle. But other than that, it's pretty much the edges of the page. So I'm going to focus on the edge of the pages first. So I'm going to go back to DESMOS here. Okay. And all I'm going to do is, come on, click off. There we go. The x equals 0 is my vertical line, and the y equals 0 is my horizontal line. So if I need more vertical lines, I'm going to click this gear icon for edit list, and then I'm just going to hit the duplicate, because I need left side of the paper, right side of the paper. And I'm going to do the same thing for y. Duplicate. Okay. And now, if you've done that, all you have to do is change this number to the edge of the paper on one side, and the next number to the edge of the paper on the other side. So you can do this one. Everyone should have the same thing, unless you have a landscape paper. Everyone's left side is -4 1/4. Okay, and everyone's right side is 4 1/4. Okay, so let me show that again. I'm going to delete these ones here. So here's the horizontal line, y equals 0. I'm going to hit the edit list, and I'm going to go duplicate. And now I'm going to, for this one, I'm going to look at my sheet of paper, which will probably have some screen artifacts here for a sec while I switch it over. And the top line here, what's the y coordinate everywhere on my top line for me? You guys looking up here? 4 3/8. That's the top line. Okay, what's the bottom line all the way across from me? Yeah, -6 5/8. And so over here on DESMOS, I'm going to have a y equals 0, but I'm also going to have a y equals, come on, is that going to, there we go, 4 3/8. That was the top line. Oh my goodness. This does not want to cooperate. 4 3/8, and the other one was -6 5/8. Okay. And if you look on my screen, is that the sheet of paper? Yeah, it's a sheet of paper with the crosshairs in it. Okay. And so at this phase, when you finish this phase, you should have your whole sheet of paper with your crosshairs. And then I'm going to pause here. I'm going to show you how to put any other horizontal or vertical lines, because I do have one to put in outside of the edge of the paper and the crosshairs. Okay, sometimes, although it won't be on every page, you'll have a horizontal or vertical line just like in the middle. If you guys will look up on the screen, you'll see that this little section right here is a horizontal line, and one way I can tell is that I have all the same y coordinates. So they're all perfect. It's perfectly horizontal. And so here's my horizontal line. To graph this line, I'm going to find another horizontal line and copy it, but there's a little extra work that I have to do beyond just what I was doing before. So I'm going to switch over to, first I'm going to note that the y coordinate here on this horizontal line is 3 1/16. That's the y coordinate. So I'm going to go over to DESMOS here. I'm going to duplicate a y equals line. I can't see, the glare is getting me right now. I'm going to duplicate this y equals line because it's horizontal, and I'm going to change it to the 3 1/16. 3 1/16. Oh my gosh. DESMOS, your formatting is killing me right now. Clicked over here. Thank you. 3 1/16. That's going to move that line up, but it's not going to clip the edges of the line. To clip the edges of the line, I have to go back and back to here. Can you guys look up at the screen for me? What is the x coordinate of the start of this line? What does it say? Not everyone at once. It's negative 1 and 7, negative 1 and 7/30 seconds, and then it ends at positive. So all I need to do, I've got this y equals 3 and 1/16. Now I need a boundary on it, which is those two numbers. So I go back to here. And then in my boundary, which is what this is right here, in my boundary, I'm going to type those numbers. So I've got negative 1, and 7/30 seconds. And then I'll just copy that, put that over here. And now I have a horizontal line that only takes up that little section right there. Okay? So if you need a horizontal or vertical line that takes up a little section, you can copy one of your other horizontal vertical lines, type in the new x or y value, and then limit it to what you need to limit it to based on your coordinates. Okay. Oh, sorry. At this stage, once you've got some lines in here, horizontal, vertical, okay, you need to save your work in DESMOS. You need to save your work in DESMOS. You have to create an account if you have not created one before. But if you have, it's probably under your student ID. And so I'm going to go up to here. Let's see here if I can. I'm like way zoomed in, so I'm going to, oh, my mouse is in the wrong spot. I'm going to click here. Okay, and I'm logged in here. But if you're not logged in, you'll need to log in or create an account. Okay, and I'm just going to, once you're logged in, you can just click save. And I'm going to save it as the airplane project. And maybe it'd be helpful to put geometry so you know what class it's from. Okay. Why would I have you save your work? Yeah, Zay? Sorry, this is on the video. So there's two reasons to save. One is so that if you come back to it later, you might not finish in one day. In fact, I'd be very surprised if you fully finished today. Okay, it's saved and you can come back to it. And the other reason is that you can share me the link, and then if I correct it and say things are wrong, you can go back and edit it because you have it saved. If you don't have it saved, it's a one-shot deal. You send it to me and hope it's good because you're never getting it back. Okay. So it's very important that you save. This is the most vital step today, is to save your work. Okay. After you've saved your work, I'm going to show you briefly how to graph a slanted line. Okay? So the first thing is I'm going to remind you, it's up on the whiteboard, but I'm going to remind you from earlier this week, okay, what the equation of a line looks like, particularly one that is not vertical or horizontal. We have y minus y1 is equal to mx minus x1, where I have the slope and one of the points on the line. And so if I go over here, I've written in all my slopes. All I need to do now is pick one point, and it doesn't matter as long as it's one point on that line. However, I will tell you that there are some cases where the point you pick can save you time. I want you to look at these two lines. Do they intersect in the same point at the top? Yeah, so if I pick that point, then when I write this equation, I've almost written the other equation. The only difference is that's negative slope right there. So I'll show you what that looks like here in DESMOS. Okay. Okay, so I'm going to go down and, gosh, she's getting the mouse over here. Go down here, going to type in y minus my y coordinate. My y coordinate was 4 3/8. Okay. Equals, my slope here was 69 divided by 68. Parentheses x minus, and my x was 0. So that's just me typing that in. Okay. I can duplicate that. And because they shared the same point, I don't need to change the point. They just had the opposite slope. I can go negative like that. Now, they don't always share the same point, and so you'll need to replace the point if the point is a different point. But that's the basics of how to get the line. But then you need to do the limits.
on that line. And so if I'm going to look at this one starts at the edge of the page on the left, which was -4.25, and it ends at 0, right in the middle. Okay. And the one down here starts at 0. Oops, sorry, less than x, and it ends at +4.25. And so I'm just putting in the boundaries of the left and right side for x. So all the slanted ones, you should put the boundaries for x between this and that. You could put the boundaries for y, and it would still work. Just make sure you're doing the y coordinates. But in general, we talk about the boundaries for x in mathematics. Your objective is to finish this and have it perfectly match your airplane. Okay? That's the objective. Now, I'm going to say this in the video. To meet standard on here is to have your crosshairs, your outline, and at least one pair of slanted lines. You guys hear me? Okay. There are different ways to exceed standard, which I'll talk about more tomorrow. But one of the ways is just to have 3 or more pairs of slanted lines. Do you guys hear me? So that'd be 6 total slanted lines, 3 or more pairs. That's one way. Okay, there'll be other ways that I'll mention tomorrow, but for the sake of this video, I wanted to mention, like, if you have more than 6 total slanted lines that you're graphing, then you're on track for an exceeding for this. Okay? All right, I'm going to stop the video there.